I welcome you to this webinar about case studies for challenging fire detection. Now, those of one who have been in my webinar 1 year ago, it's largely the same, but this time around I have a new interesting case study at the end I'd like to present to you, which is the fire protection for rooftop mounted solar panels. So stay in here. Today, I will take you on a journey to successfully design fire protection with fire detection technologies. In detail, I will present what type of detection principle can be applied in challenging environments, when standard point type detectors cannot be used, and, more important, when codes of practice and standards are sparse, which is the case for retrofitted solar panels on rooftops. After finding a suitable fire detection technology, we will soon find out what challenging environments require performance-based design. We will then see if the allegation that performance-based design is difficult and complex really is true. Finally, for the core part of the webinar, where I will show you how our case study delivers the design support you need for retrofitted solar panels on rooftops. Should you have any question, please use the chat function. I'll be answering the questions at the end of my presentation. But first, a quick introduction about myself. I started out as a hard and software development engineer before I went into project management, where I managed software development projects. After coming back to the Swiss Securitas Group a second time, I worked in consulting and corporate development. In 2018, I joined the Sales International team at Securiton as a director sales management. In my team, we mainly produce guides for our verticals library, which I will present to you as well. Please feel free to connect with me on LinkedIn. Selecting the right fire detection technology or the right type of fire detection, or last but not least, the right product, is not an easy task. We all feel pretty safe designing standard fire detection where we have experience, lots of examples to prove it works, and the codes, the standards and the codes of practice are numerous. However, as soon as we encounter a situation with a particular challenge, a set of challenges, or sparse codes of practice, it may not be so easy and straightforward, and sometimes it's hard to know what to do. Let me start our journey by making a couple of examples of what I mean when I say some challenges require special fire detection. If we, for example, have large open spaces, stratification can become a problem. If we have complex ceiling constructions, obstruction may be a problem. Or we cannot access the detector for maintenance. If we have a high airflow in the protected area, the dilution of the smoke may be a challenge. In this case, we would opt for aspirating smoke detectors to overcome these challenges. When we have other challenges, like an outdoor application with changing weather conditions, sometimes harsh, snow, rain, wind, when we have obstructed or difficult access, again, on roofs, or when the detection method is exposed to mechanical stress, we need an adequate product. In this case, for example, a linear type heat detector, which comprises of individual heat sensing elements that are encapsulated in an extra robust cable. This type of detector is especially suited for the example that I will present you later. Now we have identified particular challenges and we found a suitable special fire detection solution to deal with them. But alas, we can't find much to help us in codes and standards. Therefore, we have to apply a performance-based approach to release the full potential of special fire detection. So, what is performance-based design? Performance-based design is, and I cite Gibson here, first and foremost, the performance approach is the practice of thinking and working in terms of ends rather than means. It is concerned with what building or building product is required to do, and not with prescribing how it is to be constructed. Performance-based design approaches must consider the ultimate goal and establish objectives and performance criteria that would result in achieving that ultimate goal. These goals must be agreed upon by all project stakeholders. That includes the authority having jurisdiction, or the HJ, the owners, the design team, the end user, the insurance companies, and so on. So what do codes and standards say about performance-based design? Not much, you might say. Here, for example, a citation of the complete coverage of the performance-based design in the NFPA 72. It consists of 3 paragraphs that state what is required to document in the proposed solution, allowing the AHJ to determine that our design meets the performance objectives, and finally, that you can only make changes to the design or the solution after the authority having jurisdiction has approved them. Having seen now how performance-based design is defined and how codes deal with it, as well as where do we have experience in applying standard fire detection and what does the customer expect from us, we might conclude performance-based design is difficult and complex. I say performance-based design is not difficult and is not complex, but we must persuade the customer and we must get approval by the AHJs. The process of doing that is quite simple and straightforward. A risk-based approach to identify and address the risk and define the performance base. A risk-based approach is widely documented. Once we have defined the performance goals, as I mentioned before, they must be agreed upon by all the stakeholders. And to sugarcoat the whole thing, a performance-based design must be approved by the authority having jurisdiction. Now, you might say we haven't faced or done something like this before when we are designing with standard fire protection. This is where our case study delivers the support to argue the case with the customers, with the AHJs, and with all the other stakeholders involved in the project. So on our journey, we have now identified the challenges and a suitable fire detection design, special fire detection to address them, and we have defined the performance goals. Now, how exactly are we designing and how can a case study help us? Let me start with explaining our verticals library. Our verticals library is really your library. It features more than 20 design guides and case studies, where design guides cover a whole industry, such as warehousing and logistics, or clean rooms and otherwise controlled environments. A case study focuses on a particular application, for example, belt conveying system, recycling plants, or, as I will show you in detail, retrofitted solar panels on rooftops. Our guides, as we collectively call them, really cover a wide range of industries and application. They illustrate how design for special fire detection can be done and how it has been done. They can all be found on securiton.com. Feel free to scan the QR code for direct access. From our collection of more than 20 guides, let's look a little closer on one of the more recent ones that covers the protection of roof-mounted photovoltaic systems or PV systems. Such systems are largely retrofitted on an existing building and pose therefore some unique challenges to building fire safety. Let me show you how our guide helps you to successfully design a special fire detection solution based on a performance-based design approach. Our guides are all structured in a similar way. Let's have a closer look at aspects of fire safety and prevention. As mentioned in our guide, our guides target a specific application or industry. We introduce the application-specific aspects which fire safety design must take into consideration. In this case, we show the different types of mounting solar panels on different types of roofs and what application-specific risks we face, their consequences, and other safety aspects. Then we have a closer look at the challenges we face when designing the fire protection solution. Regarding design codes and standards, we see that currently prescriptive code does not cover, or maybe not yet cover, roof-mounted solar panels, in particular retrofitted roof-mounted solar panels. However, we see that insurers in different markets are beginning to demand solutions for the protection of such retrofitted PV systems. As codes of practice and standards are sparse, we have to adopt a risk and performance-based design approach. PV panels are usually mounted, tilted, or pitched on flat rooftops, these rooftops are usually covered with gravel or concrete slabs. PV panels can also be mounted flat on tilted or pitched rooftops. The roof here is usually covered with tin or tiles in this case. Retrofitting PV panels on shingle roofs or thatched roofs is, from a fire protection point of view, not really recommended. Mechanical damage can result from large hailstones or rockfall. Stepping on PV panels and imprudence may also lead to cell breaking and thus causing cell internal shortcuts. Damaged cells can heat up to 1200 degrees centigrade, that's just shy of 2200 degrees Fahrenheit, which can melt aluminium framing. DC isolator failures and electrical arcing in high DC voltage circuits can be a source of ignition and fire. Although the temperature of an electrical arcing varies, it was found sufficient to melt PV panel materials like glass, copper, and aluminium. These in turn lead to the combustion of other surrounding materials. The presence of PV panels, especially retrofitted PV panels, certainly changed the dynamics of a fire involving a roof assembly and increases fire spread. This can be a major concern, particularly again with retrofit systems on an existing building, where the roof can be non-fire rated or may lack of appropriate fire resistance treatment. Fire spread to weather conditions such as strong winds and close proximity of large numbers of PV panels can damage or even lead to the collapse of the entire roof structure in a relatively short period of time. The primary concerns of fire safety on rooftop-mounted PV systems are fires due to increased fire ignition sources on the rooftop cannot be detected by the fire detection system typically provided inside the building. Even buildings in 24/7 operations, fires on the rooftop can rarely be observed during the early stage of their development. Visibility can be impeded completely if a fire starts underneath a PV panel and where the roof is mostly flat. De-energizing solar panel power systems is not possible without early detection and intervention. This increases the potential for rapid spread of fire on the rooftop, aided by climate conditions such as wind and dry air. The common rack mounting of PV panels can trap a fire underneath the panels, exuberate flame-induced heat and combustibility of roof coverings, and lead to the collapse of the roof structures. Once a fire starts spreading beyond the PV panel fire of origin, the difficulty of firefighting efforts will be increased significantly due to dangerous access to the rooftop and inside the building under the affected roof structure. Other challenges include outdoor environment with a wide range of temperature changing. In cases, this change may be, in cases, even severe weather conditions. Accessing a rooftop may be difficult or otherwise obstructed, and TCO considerations. The next chapter covers optimized design and use cases, which comprises of design criteria, which is largely a summary of the key performance parameters of the products used in this application. In our case here, it will be the Securi D-List linear type heat detector, but it also gives recommendations for the protection of surrounding areas. The application scenario section, where we typically touch on risk-based detection design and system integration considerations. In this case, the case study gives recommendations for the mounting of the sensing cable In this instance, one cable runs underneath the rack structure of the roof, and another cable is running on top of each rack for optimal protection. We also give indications for the spacing and the placement and the orientation of the cable. System integration considerations cover the options to connect the Securi Heat D-list linear type fire detection system to a building fire alarm control panel. We also provide tools for monitoring the PV installation, for example, to detect unusual overheating before a fire alarm is triggered. The next chapter really is rounding off the recommendations with a 360-degree view on fire protection, which includes the features and the benefits of the solution, which you can present to the stakeholders. It gives recommendations regarding integrated verify, control, and response. And it is highlighting the non-intrusive system access for inspection, testing, and maintenance. This to overcome the challenge of obstructed access. But we also offer support, design support for you. And we add a list of source literature and additional literature. The time is a bit short to drill down in these sections, but let me conclude the journey and summarize again how case studies support you when you have a challenging project. Let me repeat, our library holds more than 20 guides. Scan the QR code, get you directly to the library. As you have seen, they cover target industries and specialist applications, especially tough fire detection challenges. Performance-based design is important to us because with a performance-based design approach, your fire protection design can reach a whole new level. But of course, we also cover codes and standards-based design. We emphasize on early warning fire detection or very early warning fire detection wherever possible, because we believe in early detection and a consequent response really saves lives and protects assets. And the best of all, they are available for free. And if you cannot find what you're looking for in our library, please do get in touch with me and we look into creating a guide for a particular application. Thank you very much. Please join us on social media. You find the respective QR codes on your screen.
Marcus, I've got a few questions.
Yes, I'd be happy to answer.
The first question is, can you give some examples of the topics that are covered by the guides?
Yes, of course. In terms of design guides, our most popular ones are probably the one covering data centers. Then distribution and warehousing is one. Clean rooms is another one when it comes to the semiconductor industry. We have separate guides to power plants and nuclear power plants, as well as electricity distribution and transmission systems. And we recently published a design guide to hospitals and large clinics, which I think will be very popular. In terms of case studies, our recent ones focusing on the hot topics like lithium-ion batteries and wind turbines are providing a hit. Others include animal sheds, recycling facilities, grain storage site, to name just a few.
Are there guides to more standard applications?
As I said, we focus on special fire detection methods, such as aspirating smoke detection and linear heat. But we do have a guide replacing point type detectors with ASDs, which shows how to get far better early warning performance and also how it can be quite cost effective in the long term.
What do I do if I can't find a guide for the application area I need?
Like I mentioned, we are continuously trying to increase our coverage of industries and where our partners are active. So that should happen less and less, that you cannot find what you're looking for. But if it does, please do not hesitate to get in touch. We may be able to point you to a similar installation or a similar case study in a different industry. And of course, we look into to add your industry if we can. We also have technicians who can advise and support you directly. And we have a design center in Asia which can assist you in designing special fire detection solutions.
Now, if I'm not a Securiton partner, can I still view the design guides?
Yes, of course. They are all available to anyone on our website, securiton.com. All you need to do is to give your email address, and then you can download all the guides you're interested in.
And the last question for today is it possible to get access to case studies and guides without a login?
At the moment, it is not possible because we believe they pose a value, these guides, and contain a lot of detail about how our product is to be applied in a particular industry or application. But don't worry, registering with us is very easy, and we won't spam you afterwards or pass on your details. It's just used by my team in vertical application management, and we send you newsletters every few months to keep you up to date. We send you invites for webinars like this one.
So thank you, Marcus, for the webinar. And we don't have any further questions, so we will end it in the next minute or two. So if there's any questions still coming in, we will be answering them by email later. So once again, thank you for the webinar, Marcus, and thank you everybody for attending our webinar. Thank you very much. Wishing you all.
Thank you. Thank you.